Okay, and moving forward to number 5. The discrete random variable x follows a binomial distribution where n equals 40 and p equals 0.27. Find the probability that x is greater than or equal to 16. A couple of things to note. So right here, this probability, I know that's not going to be in any available tables, so this is definitely a question you're going to need to use your calculator for. Also, I have a greater than or equal to probability, and we know straight away we can't calculate, or our calculators are not set up for greater than or equal to. We're going to need to do a 1 minus straight away. Let's write in that 1 minus statement. This will be worth a mark in itself. The rest of it is just typing into the calculator, and we end up getting 1 minus 0.9491 to 4 decimal places, and that leaves us with our final answer 0.0509. Okay, 2 marks in the bag. Moving on, past records suggest that 30% of customers who buy baked beans from a large supermarket buy them in single tins. A new manager suspects that there's been a change in the proportion of customers who buy baked beans in single tins. A random sample of 20 customers who had bought baked beans was taken. Okay, any clues in the question? 30%, that's what's going to be our p-value. There's been a change, all right? All he said is there's been a change. He hasn't stated whether it's an increase or a decrease, so that is my clue. I'm working with a two-tailed test. And we know we have a sample of 20 customers, so we'll come back to that. For now, let's state the hypotheses. All right, so H0, I'm looking at the probability that a customer buys baked beans is 0.3. And for H1, it's the probability that it is not equal to 0.3. All right, so what we're going to do from here. Okay, let me just state that P equals the probability buys a single pack of baked beans. All right, let's just not forget exactly what that stands for. Using a 10% level of significance, find the critical region for a two-tailed test to answer the manager's suspicion. You should state the probability of rejection in each tail, which should be less than 0.05. All right, I used X earlier in the question, so I'm just going to use Y for now. Y follows a binomial where n equals 20 and p equals 0.3. Straight away, I want to know what the expectation is. And since this is a hypothesis test where we're trying to find the critical region, let's see if a diagram can help us out. So it's two-tailed. This is a critical region. This is a critical region. I'm looking for the value here and here. I'm looking for the value here and here. One of each of those is going to be significant, whereas the other is not going to be significant. All right, we'll give it a 10% level of significance. So I know that in each of these, that should be 0.05. That should be 0.05. And even the fact that we were told 0.05 here is a clue that we're doing a two-tailed test. Okay, so the probability, looking in my tables or using the calculator, I know 0.3 and 20 are very table friendly. The probability that x is less than or equal to 3 equals 0.1071, and the probability that x is less than or equal to 2 equals 0.0355. So here we have what we're looking for, 2 consecutive values for the cumulative frequency, where one of them was significant, being less than 0.05, and the other was not. That lets me know that actually these values, this must have been the 2, because the probability that is less than or equal to that 2 is smaller than 0.05, and this must be the 3. Probability is less than or equal to 3 is greater than 0.05. Okay, let's do a similar thing, but for the top end now. So the probability, choosing a smart value in looking at the tables, try and track down something close to 0.95. So the probability it was greater than or equal to 9 is 1 minus the probability that it's less than or equal to 8, which is 1 minus 0.8867, which turns out to be 0.1133. Okay, so that's greater than the 0.05. What about greater than or equal to 10? That's 1 minus the probability that x is less than or equal to 9, which equals 1 minus 0.9520, which ends up being 0.0480. Okay, once again, what we were looking for, one of them was significant, while the other one was not. That lets me know one of them is on this side. This is going to be the 10, and one of them's on the other side. That's going to be your 9. Okay, so I've tracked down those values, but I was asked for the critical region. Those probability statements are not enough for me to have the critical region. I'm going to need to say which values as outcomes will lead me to reject H0. So it's this inequality statement that we're looking for. It's this inequality statement that we're looking for. Unless you write this by itself, you're not going to get credit for getting this far. All right, so x is less than or equal to 2, or x is greater than or equal to 10. These are the two ways that I will reject H0, and I'm going to put the union system, the union symbol in the middle, just to show that actually it could be either of these two for my critical region. Okay, let's just box that off as the critical region. Okay, next I'm asked to find the actual significance level of the test, and I'm really just going to add the probabilities of the critical region. So what was the probability that x was less than or equal to 2? It was 0.0355. What was the probability that x was greater than or equal to 10? 0.0480. Adding those together, 0.0835. But significance levels usually come as actual percentages. So what is this as a percentage? 8.35% is the significance level. So moving on. One afternoon, the manager observes 12 of the 20 customers who bought their baked beans in single tins. All right, so our observed value right here is 20. Comment on the manager's suspicion in the light of this observation. Really, the question is this significant or not? Well, it is in the critical region, meaning that actually there's enough evidence to reject H0. So there's evidence to support the manager's suspicion. Okay, be careful to make sure that you state all of these things here. It's not enough to say the manager was correct. That will not get you your mark. You need to let us know what 12 lets you know, or what's the significance of 12. It's in the critical region. It leads to the fact that we can reject H0, so that's your mathematical conclusion, which then leads on to the fact that we have evidence to support the manager's suspicion, which is the contextual conclusion. You must have these parts in there to get the mark here. Okay, finally, later it was discovered that the local scout group visited the supermarket that afternoon to buy food for their camping trip. Comment on the validity of the model used to obtain the answer in part E, giving a reason for your answer. Okay, now that I know that there was actually a scout group who are a lot more likely to buy single tins of beans, while we were conducting the investigation, it seems it may have changed our results unnecessarily. Why does it no longer fit with the binomial distribution? Well, there's some conditions for the binomial. Firstly, there should be a fixed number of trials, constant level of probability, and the binomial distribution has to be independent. And these customers, these scout members, were not independent of each other as they came into the shop. They all came in to buy the same thing. If one of them bought beans, they were all buying beans. Okay, and because of that, the binomial is no longer a good model to use, and the conclusion that we made earlier, it may not be valid. Those observed values, those observed customers, lots of them were scout members or could have been scout members, and that makes the binomial no longer a valid model. Be careful to be specific when you're responding to these context questions. You need to make sure that you're going to be awarded the credit that you deserve. So a response like I've shown will be worth all your marks.